Okay, so number 1 says, does each expression equal 2x to the 6th minus 3x to the 4th plus 1 when simplified? Okay, so basically all we have to do is simplify each of the little pieces and see if that's equal to the one above, right? Okay, so on A, how many x to the 6th do I have?
You have 0.
0.
Ooh.
No, 2.
You have 2.
There's 2, right? Because I have
Yeah.
x to the 6th minus negative, and minus negative is the same as plus, right? So this one gives me, whoa, Joe, 2x to the 6th. How many x to the 4th do I have? Remember, it's subtraction, so I have 2 minus, so negative 3. How many x squareds? They cancel, right? And then how many x's?
1.
Plus 1. So what do you think about this one?
Correct.
Correct. Okay, what about B? I have 2x to the 6th minus nothing. So 2x to the 6th. How many x to the 4th do I have? Negative 3. X to the 4th. How many x squareds?
None.
Negative x squared minus negative x squared. So that's the same as negative x squared plus x squared. 0. And then I have minus x. So is this one the same?
No.
Oh, that little trick at the very end. It looked so good until then.
I totally would have yes.
Okay, C. How many x to the 6th do I have?
2.
2. How many x to the 4th?
1.
Yeah, negative 1, right? Everybody see how you get negative 1 x to the 4th on that one? I'm going to stop right there if that's okay with you, because that is not our x to the 4th term. Okay, what about my D?
Yes.
You're already at yes. How many x to the 4th? Or x to the 6th? 2x to the 6th. And then I have, for my x to the 4th minus 3x to the 4th, there's only 1 on the left hand. My x squareds do cancel, and I have a plus x.
If you're all blue, yes.
Agreed.
No, I definitely did that out. Just did it in your mind.
Okay, so number 2. How many x to the 7th do I have?
Yeah. 4.
4. How many x to the 6th?
3.
3 x to the 6th. How many x to the 5th?
0. Wait, 0x plus 0.
Do you see how I counted it though? When you get a lot of terms like that, you want to make sure you count every term. There's no x to the 5th. X to the 4th?
Negative 1.
Negative 1 x to the 4th. X to the 3rd?
0.
None. X squared?
2.
So I have negative 1 plus 3, so 2. How many x's?
0.
No x's. And what's my constant?
Negative 9.
Negative 5.
5. Yeah. I didn't see that.
Everybody get that?
Yeah.
Okay, so be very careful. Remember this assignment I had you guys do on the tablets and you all about freaked out because of all those little details? Okay? Be very careful on these problems. They're simple, but very detail-oriented. One of those minuses makes the whole question wrong. Okay, I got 3 polynomials this time. How many x to the 9th do I have? 14 x to the 9th. X to the 8th?
0.
X to the 7th?
0.
6.
Negative 1.
Negative 1, agree with that. To the 5th?
0.
4th.
0.
3rd?
Negative
Negative
2.
3 plus 1. So negative 2. Squared?
None.
X? So 1 plus 8. Constant. Good. Everybody okay there?
Yeah.
Okay. Oh, good. Words. All right, so we have a rectangle that has a width of x and a length of, 3x squared minus 5x minus 7. Does each expression represent the perimeter of the rectangle? Okay, so how do you find the perimeter of a rectangle?
Add all the sides.
Add all the sides. So how would I do this one?
Be like 2x plus 6.
Can I say, since I have a rectangle, that two of the sides are the same? So I have 2 x's and 2 of the 3x to the third. You see what I'm saying? So we could be like, I have 2 x's and 2 of my 3x cubed minus 5x minus 7. Whoop. Okay, so if I distribute my 2, how many x to the thirds do I have? 6x cubed minus 10x minus 14. So can I combine any of those as like terms? So 6x to the third minus 8x minus 14. So is a the same as this?
No.
Which one is, what's different about it?
It has a 6 next to it.
It's the linear term, right? That's different. So that's a no. Okay, what about B?
Yes.
Yes, that one works. What about C?
Yes.
That's like literally the same. D?
Probably no.
Probably no.
It's not deep.
Yes.
2x plus 2. Yeah.
2x plus 2, what?
2x.
Oh, so to do the perimeter of a rectangle, I have 2 widths and 2 lengths, right? So 2 widths, so I have 2 x's and I have 2 of these. So 2 of these. See what I mean? So this is grouped together as the length. Okay, so look at how many adding and subtracting ones there are. You guys should be nailing this quiz. Those are easy, right?
Except long ones like this.
Except for this one right here, that's totally hard. Huh? Yeah, this is all one question. Okay, ready? So how many x to the 10ths?
Okay.
So I have negative 7
Plus 2.
plus 2, so negative 5
You have negative 8.
minus 3.
Negative 8.
Wait. Negative 5 minus 3. Oh yeah, you said negative 8. I agree. Okay, do we have any ninths? To the ninths?
No.
To the eighths?
No.
Sevenths?
No.
6.
Yes.
Okay, so I got 2 minus negative, so that's a plus. 2 plus 1
Negative 1.
minus 4.
Negative 1.
Negative 1. So negative x to the 6. Any fifths?
No.
Fourths.
Yes.
Ooh, there's a fourth there. Negative 5. Thirds.
Yes.
So negative 3 minus 1
Negative 4.
plus 1.
Negative 3.
Negative 3. Squareds?
No, what?
Linears?
No.
Constants?
Yes.
So I have
10.
negative 2 plus 8. Negative 2 plus 8. 6. Everybody follow that? That constant's tricky. Tricky. Okay, number 6.
Okay.
A rectangular swimming pool has a perimeter of that feet and a width of x. Find the length of the pool when the width is 24 feet.
So we could just.
You just plug in 24 for x. Oh no, wait.
24 is the width, right? So 24 is the width, and the width of...
It's just 2. Or it's in the whole perimeter, it's just 2.
Okay, so you kind of, yeah. Okay, so It says the width of x, right? And the width is 24. So what do we start by doing? Okay, we do plug 24 into the x. Okay, but remember, what is this equation representing? Perimeter. So our perimeter, we're going to plug 24 in and get apparently a gigantic number, because 24 is a big number. Can somebody type this into the calculator, please, for me?
What if you get?
What?
Oh no, wait, never mind. I was just looking at, you put 24 in parentheses. Do you have to do that? Will it change?
You don't have to, but I use parentheses always when I plug a number in.
I did it.
Just always get in the habit. What'd you get? 170, 170?
Yes, that's it.
Oh, I was expecting a way bigger number. Okay, so 170 is the perimeter. Okay, now it says that we have a width of x. How can we figure out the length?
You subtract 2x.
Okay, so first of all, what is the definition of the perimeter of a rectangle?
2 width over 2 widths.
Good. 2 widths plus 2 lengths. So if we know that our width is, what was our width again?
24.
24. We know our width is 24 and our perimeter is
170.
170. See where we're plugging stuff in now?
Yeah.
So we're going 170 is equal to 2 times 24 plus 2 lengths. So what is 2 times 24?
48.
And then what would I do?
You subtract 48.
Subtract. So what's 170 whoa.
Yes.
And then what?
You divide by 2.
And what's that? Ooh, got some competition going on. So 61, and we want to make sure that we label it if we can. 61 what? Feet. Okay. So that was the second question regarding the rectangle, what am I talking about? The perimeter of the rectangle. There it is. So interesting. Might want to make sure you know that. Ready? You guys are ready?
Yeah.
You don't want me to keep going? We've only been adding and subtracting.
To the harder one.
Oh, okay. How about 7? Is 7 too easy?
Yeah.
Okay, then tell me which rule it is. Oh, you guys are so easy. It's a what? Okay, fair enough. Difference of squares. Everybody okay with difference of squares?
Sure.
A plus B, A minus B. Anybody want to tell me which one that is?
I guess if you keep.
B. Good. Okay, how would you do number 8? Multiplying 2 trinomials.
So on the previous one would be the only yes. Because it
Well, maybe, yeah.
that is also factorable. That is also a difference of squares. So it'd be this one, this is a yes, and this is a yes. Because this one results in these two.
Oh, gotcha. So you just foil it, and you foil it to try and get the.
Are we still talking about 7? Factor.
Oh yeah.
Factor it. Yep, factor. And anytime you get a quantity that's not linear, you always see if you can factor that further. So don't stop if you have something that it has an exponent. See if it can go further. It might not, but always see. Okay, how do you do question number 8?
You like distribute.
Yeah, right? Do I need to go over foiling this?
And then you add like.
And then add like terms? You're good there? You guys got that?
Yes.
Okay, what about 9 or 10? Using Pascal's triangle. Even if it says binomial theorem, I want you to use Pascal's triangle.
Can we do that? Yeah, I'm so confused on that.
No. It's easy. It's easy.
No. It's hard.
Right.
Okay, let's do number 9. Okay, we have it to the 7th power. So what row do I have? You might not have this written all the way down to 7th row in Pascal's triangle.
think I have much farther than that.
Do you?
Yeah. I went down to the 10 Pro.
You did? Wow.
We're doing 8, we're not 10. Like, that's smart. Yeah, I found the one with this.
So this is the one that we are using, right?
Yeah.
Okay, so I'm just going to write this right here where I have lots of space. Seven. Oh gosh, I'm going to have to make this smaller. 1. So over at my polynomial, my a is x and my b is 7. Okay, so what do I do with the x piece? So I start on the first term with x to the 7th, right? So I go x to the 7th, x to the 6th, x to the 5th, x to the 4th. This will be worth 1 point, you figuring out how to just simply use Pascal's triangle. Okay, and then my 7 starts on the other ends and comes back. Oops.
Why is there a 7 in parentheses?
Because that's the number from the binomial.
Oh, okay.
So if this is a minus, how do I do my terms? What's the first one? Oh, it's a good thing we went over this. If it starts with a minus, the first one is a minus, and then it alternates. Whoops.
Yeah. So,
Pluses just stay the same. Pluses, pluses, but when it's a minus, the minus alternates every term. Now that looks pretty awesome. Looks like a lot of jumbled together. Okay, so then I have to simplify each of the terms. So I have x to the 7th. Okay, first term I have 7 times 7. What's 7 times 7?
49.
Okay, I'm going to need a calculator here. Okay, third term I have 7 squared times 21.
1,029.
1,029.
Yes.
Okay, next term is 7 cubed times 35. What?
Take it away, Travis.
12,005. 12,005. Wow.
Alright, stop.
Okay, what is 7 to the 4th times 35?
84,035.
84,035. Okay, then 7 to the 5th power times 21.
Oh, 300.
5,000. No, wait, no.
352,947.
Dynamic duo.
Okay, what is 7 to the 6th times 7?
Oh gosh. 823,543.
823,000 what?
543.
43.
Wait, should the 8,435 have a exponent?
Oh, an x? Maybe.
Or yeah.
Yeah, good catch. Thank you. So that means this one needs an x too. I almost forgot that one. And my last one is 7 to the 7th power. 7th power.
Same thing as the last one.
So there you go. Hope there's not one that big on your test because you might need more paper.
I didn't like it.
That's pretty awesome though. Can you imagine having to FOIL that out 7 times?
No, I wouldn't.
That would
I'll
suck.
say no.
I just
Can we get an exempt from probably?
I don't think it is on here. Alright, 11. What radius of a cylinder is x plus 2 and its height is that? Find a function for the volume of a cylinder Ooh. So do you guys know how to find the volume of a cylinder?
Times pi.
Base times height, right? It is base times height. So it's the area of the base. So what's the area, what is the shape of the base of a cylinder? Circle. So the area of a circle is pi r squared. So we're going to do pi r squared times the height to find the volume of a cylinder. Might write this one down. Okay, so this one says the radius is x plus 2. So I'm going to replace the radius with x plus 2. And the height is x squared minus 3x minus 2. Okay, now it says find a function for the volume of the cylinder. Can I stop where I'm at right now?
No.
Sure can.
Does it say write it in standard form? No. Okay. This is technically a function. Okay. I have an equation, I have an x. I don't have to do anything fancy unless they specifically say put it into a certain form. If they said write the function in standard form, then I would have to do some foiling. Okay, but if they don't, then I'm not going to touch it because that way I know I'm not going to make a mistake. Okay, number 12. What do you guys think about this one? Choose true or false for each of the statements. Do you guys want to talk about this one? This is factoring this. Are we okay with the factoring with the...
I just don't understand.
You just don't understand words? Oh, so we need to go over this one because there's words? Okay, so it's just asking true or false about this particular polynomial. So how would I factor it? It's all asking about factors. So how would you factor this?
Difference of school.
What is always the first thing you try? Greatest common factor. Can you pull a greatest common factor out of this?
Yes.
Yes, for
Y.
y. Okay, so you pull out 4y. What's left over?
X squared, please.
16. No, you're right, 4. My bad. 4. Okay, now am I done? Do I just stop right there?
No.
No. Okay, so I have that quadratic piece. Can I factor the quadratic piece further? Is x squared minus 4 factorable?
Yes.
It is. By what?
X and 2.
Okay, so it's a difference of squares.
And
Yeah, so it'll be x plus 2 and x minus 2. Okay, so A says, can you factor out a greatest mononomial factor? Do you guys know what mononomial means? It means one term. So did we factor out a greatest common factor?
We sure did.
We sure did. Can you factor by grouping?
no.
Did you use the grouping method? Were there 4 terms involved?
No.
No. Can you factor using a perfect square trinomial?
No.
No, there's not trinomials ever in our case.
Yes.
Can you factor using the difference of 2 squares pattern?
Yeah.
Yep, we did that last. Oops, yeah, yes. Okay,
You're back.
there is a back.
Wait, this isn't the test.
No, we won't do all of it. Let's see. I think, do I need to go over this one? That one's pretty straightforward. Irreducible means not factorable. Okay, so maybe a better way they should have worded that is that factorable. So, okay.
Wait, irreducible means not factor?
Yeah, not factorable. Do we need to go over any of the factoring methods? I feel like you guys did pretty good on the factoring. Okay.
Factoring just.
There's either, it's going to be a special case or, well, actually, all 3 of these are different cases. This one, does anybody recognize this one? If you look at the first number and the last number, what kind of numbers are those? Perfect squared. Okay, I also see 3 terms. So which special case is that? Perfect squared trinomial. What's this one? 4 terms, grouping. Those are super easy to identify. 4 terms. Greatest common factor first on this one though. Yes?
What's grouping?
Where you group the first 2, group the last 2, and then you pull out the greatest common factor.
And
It's within the hard method.
so would it be like 3?
The greatest common factor?
Well, yeah, the greatest one would be 5 for the first one, and 2 for the next one.
Negative 2x squared.
Yeah.
Yeah.
And yeah, put the ones you pull the outside in. As well.
Yep.
Wait, how do you do the X?
Exponents?
No, 16.
Miss Melty, there are people outside the door.
What are they doing? Are they staring at you?
Yeah, for like 5 minutes, I'm trying to wait.
Who are they? Do you know who they are?
They're Topsley, Rock, and then Austin. Yeah, they're for like 5 minutes.
Were they trying to get my attention like they were waiting, or they're just sneaking around?
And then when I said something, they were
This one would be, okay, this is kind of a tricky one because do you guys remember that one I did on the warm-up?
Would it be 6 squared greater than X?
You want to do, if you can do a difference of squares, you do that first, as opposed to a cube. Okay, so I would do a difference of squared on that and then go further if you can.
Wait, so.
So always do a difference of squares if that's a possibility.
Could you do that like
Wait, so what do you do?
this here?
So it'll be x to the third.
Plus y to the third and then x to the third minus y to the third.
Yep.
Can you do that?
No.
Oh.
No. What?
What's this?
Like not factorable. Can't factor it.
What was
You want to do a difference of squares on that first. And then you'll have to use a difference of cubes and a sum of cubes. That one's factorable twice. Do you guys have the probability stuff in there in your notes?
But I don't understand.
So we need to go over the probability.
Yes.
Okay, so you guys have the definition written down? Make sure you have it written down. Oops, that was a terrible cue.
Oh, this is gonna be on there?
Okay, so we consider a cafeteria that has 5 desserts available. One of the desserts is pie. The rest are 4 different kinds of cakes. Sounds delicious. 4 customers are in line to choose a dessert. Okay, what is the probability that exactly 3 of the people will choose pie? Okay, so let's identify the variables. N. Okay, N is the number of opportunities.
That would be 4.
Okay, how many people are in line? 4, very good. Okay, our R is how many successes we want of those 4 people. How many are we looking for? 3. Our P is the probability of choosing a pie.
Oh, gee, that one.
Okay, so if the cafeteria has 5 desserts, one of those desserts is a pie. So what is the probability you'll get a pie? 1/5. What is the probability that you will not get a pie? 4/5. Good. Okay, so now you simply plug this into our little formula. So it's going to go 4 combinations of 3 times 1/5 to the 3rd power times 4/5 to the, can I go ahead and jump to 4 minus 3 being 1? 1 power. And everybody's okay with how you type that in the calculator?
No. You multiply, you go to math and you go with it.
Okay, you start by hitting whatever your N is. So, yeah, 4. So you're going to hit 4, and then you hit math, and you're going to go to probability. Okay, and the 3rd option is your combination, so you can hit 3, and then we type up 3. Make sure afterwards you hit times, and now we're going to do 1/5. So 1 divided by 5 to the 3rd power. and 4/5 to the first power. I don't really need to say first power, but what the heck. Okay, so what percent would you say that is? Yeah, let's call that 2.6. Okay.
So what happens when it says at least?
Okay, now if it says at least, so this is the scenario where you have at least. Okay, so what you have to do is you have to say, if I'm going to get at least 3, then what are the scenarios where we get at least 3? 3 out of 4 or 4 out of 4. So you have to do 2 separate combinations. You have to do a 4, the one we just did, and a 4 out of 4 scenario. 1/5 to the 4th, 4/5 to the 0, and add those 2 together. Okay. Okay,
Wait, so,
we're out of time.
so,
We don't have to take the quiz?
No, we're out of time for reviewing. Okay, the rest of this is what we learned yesterday.
Alright, that should be easy.
Yeah, we're good.
So hopefully that's still fresh in your brain. All right, so